And so the last talk in this session, we have Moumita Bhattacharya from Netflix, and we're still talking about session recommendations.
Thank you. All right. Hey, everyone. I'm Moumita Bhattacharya, a senior research scientist at Netflix, working on the search and recommendations team, the team that tries to improve contextual recommendation on Netflix product. And today I'm excited to talk to you about how we build this model for powering anticipatory search on Netflix using in-session and cross-session recommendations. All right. First and foremost, huge shout out to my stunning colleagues on Netflix without whom this work wouldn't have been possible. Here's a list of their names. Let's get started. So as we all know, recommender systems are a critical component for any online products as they enable users discover the most relevant product that they are looking from a large catalog. Be it content streaming service such as Netflix or music streaming service such as Spotify, e-commerce platforms such as Etsy, surfacing the right product to the right user at the right time is a difficult task, as the recommender system has to constantly adapt to the user's shifting needs. However, building such a system is a challenging task because the user taste evolves over time and their multifaceted interests and needs are different at different times. For example, on Netflix, our users often wonder what they should watch from a huge catalog. And it's also difficult to capture the members in the moment or their now intent. One option is for our members to search for something and based on the search results, try to find what he or she wants to watch. Search is one of the primary ways for our members to find something to watch on Netflix, second only to recommendations on the homepage. In fact, 20 to 30% of discovery on Netflix happens via search. User studies have revealed that our members typically have 3 different mindsets when they search on Netflix, namely fetch, find, and explore. Fetch intent is as it sounds. The user have a clear intent of retrieving a specific item from the catalog to stream. For find intent, usually the user has formulated their entertainment needs, but they do not have a specific item in mind. While explore intent is when the user have a very broad concept in mind, for example, horror movies or Spanish movies. The role of a search system in this explore use case is to provide a slate of relevant recommendations or titles to the user and guide them through a meaningful journey so that they finally find something on the product to start watching. And we argue that for such use case, it could be a delightful user experience if we can identify these explore use cases and preemptively show recommendations to the user before they need to start searching. Although almost all of our members searches at least once a month, typing a query still has its friction points, especially on a large device such as TV, such as 10 feet TV device, where typing is tedious and often error-prone. We try to improve this experience by anticipating what the member is about to search for and show corresponding recommendations in search before they have to start typing. Such recommendations are often also referred to as anticipatory search or pre-query recommendation. And in this work, we argue that such recommendation can really benefit from leveraging members within session browsing signals and make the recommendations adaptive to the members in the moment or their now intent. In fact, a lot of our members engages with homepage and other parts of the product before landing on search, before navigating to search. These search sessions have the opportunity to use the members' recent browsing signals within the session to generate recommendations that are attuned to the members' in-the-moment need. And unlike most other recommender systems that have accurately been learning user interest profile based on their past viewing history, their long-term interest, and based on behavior of similar user, this kind of recommender systems requires an approach that not only learns the user long-term preference, but also utilizes their short-term in-the-moment preference, yielding an in-session adapted recommendations. Notably, a previous work from Netflix research by Wu et al. have shown that leveraging such within-session user navigation pattern for adopting recommendation in real time indeed generates more relevant recommendations. As we would imagine, there are lots of benefits of such in-session adopted recommendation, some of which is listed here. It enables us to generate more fresh recommendation and hence increase freshness of the recommendation, inject diversity, because we are now more attuned to the user in the moment intent, and not only just long-term preference. It increases novelty and made the findability easier. And most importantly, such method really helps in improving user cold starting, especially that is for users for whom we do not have a lot of historical preference understanding. We can leverage these in-the-moment engagement to predict what the user might like during the current session. Ultimately, all this would lead to spark member joy, reduce abandoned session, and hopefully increase member satisfaction. Now let's look at what approach we took to solve this problem for such anticipatory search on Netflix. A quick high-level overview of the in-session adapted pre-query recommendation on our system. Very, very bird's-eye view of the system. In no way it's a representation of the complexity of the actual ecosystem there in Netflix. So let's say the member comes to netflix.com and comes to Netflix search. The client triggers a server call. The server then passes all this information needed along with user in-session browsing signals to the online ranker to generate fresh recommendations. Now, these freshly generated recommendations are then passed back to the client to be surfaced to the member in real time. There are all these other things that needs to happen in the meantime while we are freshing the fresh recommendation. Things like latency consideration. We need to be able to show the fresh recommendation that is attuned to the user short-term intent without the user realizing that the model is doing all this work. Of course, we also need to figure out how to reliably log these different feature values and the engagement that the user did. Let's dig a little bit into these considerations. One of the key requirements to design such a system is to fetch the rank results as close to when the user will see them, so that all the within-session engagement until then can be taken into account. To achieve this, we need to have a live request to the server triggered when the user is about to see the recommendations. That is, when a user comes to the page, the client would need to make a call to the service at that moment and within acceptable latency, render fresh recommendation. And I think this is very key. Like within acceptable latency, it really puts a constraint on the model complexity, on the kind of signals we can use to infer from the model. Moreover, we cannot fetch the results from previously cached result set, as we want fresh recommendations to be generated using the actions that the user undertook on the platform up until then. Moreover, the increased number of server calls and no caching can potentially cause more errors and timeouts, which we need to handle. Additionally, the user interaction in a given session needs to be passed to the machine learning model in a near real-time fashion, such that the model inference can take these signals into account. All these considerations make such real-time recommendations with in-session signal as much as a large-scale engineering task as it is a machine learning modeling task. All right. Now let's look a little bit around how do we build this model, what are some considerations. As you would imagine, to do such in-session adaptive recommendation, we can build a generalized, personalized recommender system, and that's what we do. We build, in some sense, you can call it a content-based recommendation system that is using user within-session engagement. And most of the modern recommender systems is much more nuanced, so we take into account a plethora of information about the item, about the user context, and user-item interactions. Although we do not use any user demographic data, we do take into account profile level settings. So for example, profile maturity level associated with the account, the user country and language associated with the profile. We also include a ton of title level information, such as embeddings generated from the user, from the title video, title script, popularity level signals about the different titles, the different genre information, and also multitude of interactions, such as playing a title, adding to MyListat, and so on. While all these are kind of a general personalized recommendation systems, characteristics of the general personalized recommendation system, how we inject the in-session signal is by taking into account these different engagement that the user did within that current session, the browsing signals. So such as whether the user is interested in comedy titles in that session, or whether the user has interacted with a lot of action titles in that session. So we then take those information and generate a lot of engineered features, as well as take into account the user raw engagement sequence. And all these things together makes the model very attuned to the user short-term intent via those in-session signals, as well as the other user preference, long-term preference is captured from the historical sessions. In fact, for our Netflix pre-query recommendation system, we built such a model which showed around 6% offline metric-based improvement. And we tried different kinds of offline metrics, all sorts of ranking metrics. So one step further would be to add not only the user current browsing signals, but also in-session as well as cross-session signals. And that's what we do. One thing to keep in mind when we start adding cross-session signals along with in-session signals is how do we balance these user short-term intent being captured by in-session signals while the cross-session signals gives information about the long-term intent. As you can imagine, given all these input data, there is a wide variety of model architecture that we can leverage to effectively capture the user short-term and long-term intent. And we experiment with different types of deep learning architecture and objectives, including leveraging a lot of dense features, as well as raw engagement sequence, temporarily sorted in time. And the raw engagement sequence kind of complements the carefully engineered features by bringing in certain signals that the carefully engineering signals features might have missed. Quick example here. So this is an example from a real Netflix user where the user comes to Netflix pre-query and sees the recommendation on the left column. Then she decided to do some browsing on the home page and looked for some titles that has women in the leading role. And to her delight, when she went back to search pre-query, she found some titles like Gilmore Girl, Emily in Paris, New Girl, which are all titles with women in leading role. So just to point out, this is all adopted in that session, so in real time. And then she changed her mind and started browsing some baking-related shows. And ultimately, her pre-query recommendation was a combination of her current interests, which is titles with women in leading role as well as baking-related shows. All right, quickly touching upon some of the challenges that we faced as a part of this, embarking in this journey of adopting recommendations in real time. One of them is for us to, sorry, the screen is very small here. So one big issue is, with such in-session adaptive recommendation, we can really burst filter bubbles. So we can enable the user to really start exploring some diverse titles beyond what the user would typically see on their recommendation on the homepage. And this helps us to show diverse titles to the user, but in order to do this, we need to take into account not only the user long-term preference, but the short-term preference. But at the same time, just taking into account user short-term preference can also create more concentration effect, and we don't want to do that. That's kind of the critical takeaway message here. Also, there are many other challenges, such as because there is more server call, there could be increased timeout. We cannot use caching. So all these things need to come together for such in-session adaptive recommendation. Just to conclude, we do see that leveraging such user real-time browsing engagement can effectively capture user short-term and long-term intent. But building such an in-session recommender system is as much as a modeling task as it is an engineering task, and several infrastructural and modeling considerations needs to come together for a successful in-session adaptive recommendation system. Thank you. Happy to take any questions.
All right, thank you. I'm afraid we're actually out of time, and I'm not going to be able to take any questions
Okay.
for you. But there are some interesting questions there. I
Okay.
encourage you to take a look at what shows up on the page. And we are over time for this session as a whole. We're now about to have our break. Don't forget that there are posters next door, including the late breaking results posters, and I'm not just saying that because I have one there. And I'm also supposed to point out that this break is brought to you by Netflix.